Good morning, students. Now we are going to understand how to proceed for the frames which are having unsymmetry of loading or unsymmetry in the geometry causing the sway of frame when the loads are being applied. The frames which are having this kind of nature, when they are being analyzed by the method of moment distribution, we need to follow certain steps. So the entire frame would be analyzed using two important steps. First is the non-sway analysis, as you were doing for any simple frame which was symmetrical for loading and symmetrical for geometry, or the beams which you had been already attempting with the moment distribution. Then after the sway analysis, at the end of analysis, you would be able to find the reaction at the bases of the column, which will let you know what is the exactly unbalanced horizontal force acting upon the frame causing the sway of the frame. Then, assuming some arbitrary value of sway force, say P, and find out the find out the moments in the columns due to this applied sway force P at the top of the column. At this stage, you have to ignore all the loading acting upon the column. Find out, after going through the sway analysis, certainly you will have some moments at the base of the column and at the top of the column. For these values, again go for the moment distribution and do the sway analysis. At the end of the process, you will again find that what is the net horizontal unbalanced force at the base of the column. The entire process which I have explained till now, I have explained with the problem. Say you can notice a problem, a frame which is having the unequal length of the column loaded with a load of 50 kilonewton meter. In the non-sway analysis, you will go for the finding the distribution factor at the joints. After finding out the fixed end moment in the beam BC, then here you have done the non-sway analysis, in which the horizontal reaction at the base of column A, that is HA, and at the base of column at D, that is HD, you can find out. So difference of the two will let you know what is the exact value of the sway force. Then remove all the loading in the sway analysis. Allow the frame to sway as shown in this diagram towards left. So due to sway of the frame towards left, the moment in the column AB and CD will get produced in the clockwise nature, and that would be equal to 6 EI delta L upon LAB square in the column AB and 6 EI delta upon LCD square in the column CD. Solving further, you will find some certain ratio between the moments in the column AB and column CD. Assume some arbitrary value as per your choice, maybe 9 kilonewton meter or 8 kilonewton meter or multiple of 9 and 8 in the column AB and CD respectively. Here I have taken the moment in the column AB as 9 kilonewton meter and in the column CD as 8 kilonewton meter. Again with the same distribution factor, I have gone for the moment distribution, and at the end you may notice here the horizontal reaction at A and at D in the column AB and CD has been computed as usual, as which is known to you. Then you will have to find out the sway correction factor, which is what? The actual sway which you have obtained during the non-sway analysis, that was the unbalanced horizontal reaction in the column AB and CD divided by the assumed sway force which you have just now solved with the sway analysis, that is again the unbalanced horizontal reaction in the column AB and CD. So the ratio is coming equal to 0.113. Now how to find the final value of the moment in the column? So make a table, observation table, enter in the rows as I have entered here, moment in AB, moment in BA, moment BC, CD, CB, CD and DC. First row, enter the values of non-sway moments which you have obtained during the first cycle of moment distribution with sign. Then enter the value of sway moments which you have obtained at the end of sway analysis with sign. Now multiply the sway moments with the value of sway correction factor, that is the row 3. Now add the row 1 and row 3 all together to find the final value of moment in a particular uh, member of the frame, either it is a column or it is a beam at particular joint as shown in the last row here. So thank you. This was the first case when the geometry of frame was not symmetrical, but the load was symmetrical upon the beam. Now we will further learn how to handle the case of the frames which are having the inclined leg. So for that you have to wait for the next video. So then after finally getting all the values at the base of the column and all, the beam and columns, they can be analyzed for their reaction forces or and the moments, and the required shear force diagram can be drawn as shown here in the illustration, and the required bending moment diagram for the frame can also be prepared as per your previous knowledge. Understand that we are assuming that when the column is bulging inside, the moment would be taken as positive, and if the column is bulging outside, then the moment would be taken as negative. For beams, sagging is positive, hugging is negative. Next, a frame which is having the pure force which is causing the sway. One more problem I have discussed here. So you can notice a frame under the load 50 kilonewton acting on the frame from left to right, causing the sway towards right side. For this, you have to start with the non-sway analysis, find out the distribution factor. Notice that there will not be any fixed end moment due to the loading, because there is no load acting in between the two joints. The load is acting only at the joint. So in this case, only we will have to go for the sway analysis. So after finding the distribution factor, assuming some arbitrary value of moment in the column AB and CD from left to right, if the sway is taking place, then the moment which is going to be produced in the column would be anti-clockwise in nature, since the base of the column base of the frame at the base of column D is hinged. So therefore the fixed end moment induced at C would be 3a delta upon L square. Length of the column in both the cases is same. So assuming the some arbitrary value of moment in the column AB and CD in a ratio of 2:1 as computed here, then we can go for the regular moment distribution for the sway analysis as shown here. So I have assumed the value of 20 kilonewton 20 kilonewton meter in the column AB, and in the column CB it is 10. Notice that at D there will not be any bending moment, since the end D is the hinged end. After going with the proper moment distribution process, you can notice that the horizontal reaction at A and D is obtained as 1.53 kilonewton, and at D it is 1.53, and at A it is 5.24. So the total force which is causing these reactions to happen in the frame, that would be the summation of these two reactions, because they were acting from right to left. So a sway force which is acting from left to right is 6.77 kilonewton, which is causing the generation of the reaction at A and D in the horizontal direction of magnitude 5.24 and 1.53 kilonewton respectively. Further, to find out the final value of the moment in the column and at the joint, again you have to make one observation table. Enter in the first row the value of moment at joints, which was initially computed as the sway value. Then multiply the values with the sway correction factor, which is the actually acting sway force of 50 kilonewton divided by the assumed sway force of 6.77 as computed earlier. So multiplying the values by 7.38, the final answer is listed in the last row of the table. After finding these values, we can go for the analysis of uh, all other reactions, and finally we are in a position to find out the shear force diagram and bending moment diagram as shown. One more problem of different variety, that is the case of the box type of frame. You can notice A, B, C, D is a box type of frame. You can imagine a small culvert or the small bridge along a roadway, that we make a container of concrete A, B, C, D. So if the load is acting upon the BC, which is external in nature, the sides AB and CD will receive a load from the surrounding earth mass. So that would be the since B is at the top of the road, so therefore the distribution of load along the wall AB would be triangular in nature, as in case of the dams and the retaining walls. Similarly, the loading for CD will also be the same, and upon the part AD, which is in contact with the earth's reaction of 10 kilonewton meter would be acting definitely there. So first of all, find out the fixed end moment in all members AB, BC, CD and DA with proper notation and taken as you have learned in case of the moment distribution and slope deflection earlier. Then find out the distribution factor at all four joints. Notice that at joint B, members are there BA and BC, at C, CB and CD, at D it is DC and DA, and at A it is AE and AD. Okay, so you might notice that in all the members for the distribution factor is 0.5. Now it is the time to go for the moment distribution. So from A, moment would be carried over to the far end D in the member AD, and from in case of the joint D, the moment would be carried out from the joint D to the far end A and vice versa. So after running the cycle of the moment distribution, since the values are same, not so difficult. After 2 to 3 cycles, you are able to find the stable values at the end of the distribution. You are able to find the final values of moments at the base as 8.20, 8.20 at the last row of the column, last row of the observation table. Finally, you are able to find the reaction at AB, moment in AB, and then you are able to find out, you are able to analyze all the beams for the moment and reaction for drawing of the shear force diagram and bending moment diagram as indicated here. Then after, there may be the frames which are having the inclined basis. In case of inclined basis, there is a need to understand, to analyze the geometry of the frame first of all, because it is going to interfere the entire computation. As you can notice in this problem, the length of AB is 3 meters only, and the length of CD, which is inclined in leg, is to be computed. So first of all, find out the fixed end moment due to the load acting upon the part BC. Then go for the finding out the distribution factor as usual. Now going for the non-sway analysis, at the end of the observation table, we will come with the value of final moments at the base, at the joints. Uh, as here in case, you will find the moment in AB as 8.17 clockwise in nature, moment in BA as 16.37 which is clockwise in nature, moment in BC as minus 16.37 anti-clockwise in nature, and so on. So this is not so different from the process which you have already tried many times earlier. It is the simple process of moment distribution, that is the non-sway analysis. Now, before going for the sway analysis, this step is very much important because you need to find out the horizontal force causing the sway. For that, watch the figure carefully. The frame ABCD, in the frame ABCD, I have extended the member CD in upward direction to meet the member AB if extended at O. Let us understand the distance BO is equal to X. Alright. The non-sway moments are allowed to act at the joint A and joint D as shown here. The reaction at A, HA, is mentioned, and the reaction at D would be acting along the HD as noted here. Alright. So in the figure, in the triangle OBC, triangle CD2D, triangle CD1D, we need to find some parameters, some distances, so that you can move further. Say x1, which is the distance D to D, is 2.25 meter as computed by the using the property of similar triangles. Then the distance AD3 would be addition of the initial distance between AC, that is 5 meter, plus x1, that is the 2.25 meters, that is total is 7.25 meters. Again apply the property of similar triangle to find the value of OC like this. So then the total horizontal reaction at A you can compute as per the previous learning, and the reaction at D you can find the value. Alright. So the total, to find out the sway force P1, we can take moment about O of all the forces as indicated here as per the figure. You can notice I have drawn everything very much clear here. This is the figure pertaining for the computation of the horizontal reaction at D or reaction along HD. This is the figure by which you have computed the horizontal reaction at A. Notice that the moment at A is clockwise in nature, moment at B is clockwise in nature. So therefore the direction of HA should be such that HA must make some anti-clockwise moment at B. Notice, place the direction correctly so that you don't make a mistake. In this case of column CD, the moment at C is anticlockwise in nature, and moment at D is again anticlockwise in nature. So the reaction at D would be such that it can make a clockwise moment about C. This way you are able to find the value of HA and HD on the first line, in the first line of this page. Okay, then finding the force P, you have taken the reaction of HA, HD, everything, all forces which are there in the geometry about O, and you will be able to find out the value of the actual sway force P. Alright, that is the, basically you need to learn the concepts of engineering mechanics and strength of material, how to find the reaction, how to find unknown force. There is nothing to do with the moment distribution. This part was only purely pertaining to the mechanics and the so on. Now, when the sway force is acting upon the frame, it will cause the sway. It will cause the sway in the columns and the displacement in the beam BC, as indicated here in the diagram. You can notice the point B has transferred to the point B1. It is a pure translation. The joint C has moved to the joint C2. Notice Joint C has moved to joint C2, and if I analyze the CC2 into two parts, one is the vertical component C2C1 and one is the horizontal component CC1. Okay, so further analysis is being made in this diagram, that how the relationship between the CC1, C1, C2 and CC2 takes place. Notice, if I say CC1 is delta, then CC2 is to be computed, and C1, C2 is to be computed by the geometry of the figure at joint C, when the displacement of the C takes place from C to C2, C to the position C2. Okay, so this is again a geometrical analysis, and students, I have noticed that many of the students, they are not able to establish the relation between delta, delta 1 and delta 2. That becomes a problem. So after finding the values, the relationship between the moments due to sway in the column AB, in the beam BC and in the column CD can be established in terms of one value, so that is delta. Notice carefully, you can find the values here like this. Alright, now initially assuming some primary value in the column AB as per our own choice, say 50 kilonewton meter, to start the cycle of moment distribution for the sway analysis as we were doing earlier. Then the value of EI delta can be computed, that can be placed in the other equations to find the value of MFBC and MFCD as well. You can notice it is minus 13.5 and 22.5 respectively. Then after finding the values in the column AB, beam BC and column CD, with the calculated value of moment distribution factor, we can go for the moment distribution for the sway. At the end of the entire distribution, after running the cycle of correction 3 to 4 times, at the end you end up with some values at the base of the column or at the joint. Okay, then again you need to find the horizontal force at A and the reactive force along HD at D as usual. So finding notice the moment at A is clockwise, moment at B is again clockwise. So the HA should be in such a manner so that HA can make a reaction about B, which is anti-clockwise in nature. Moment at C and D is again clockwise in nature in the last row. So therefore HD should also be have that direction by which the HD is able to create a moment of anti-clockwise nature at C. Alright, so thus we are able to find the force P2 which was there, assumed sway force causing the development of the reaction at A and D, HA and HD. Alright, so sway correction factor, initial sway which was obtained during the non-sway analysis was minus 8.97, and the assumed sway force just now computed was 44.87. So we are able to find the value of sway correction factor as minus 0.2. Then the final moments can be obtained using the value of computed values as above, and finally we are in a position to find, after finding the values, we are able to prepare the shear force diagram and bending moment diagram as explained earlier. Similarly, on the same lines, I will leave this problem for you. One more inclined frame is there, having the leg AB inclined towards left. On the same lines, we are able to solve the question. Analyzing the geometry of the figure when the sway will take place, in this diagram, figure small b and figure small c, we are able to establish a relation between del 1, del 2 and del, as mentioned here. Del is the downward deflection of the member B to the B2. Del del 2 is the translation of the point B to B1. All right, like this. So it is application of simply geometry. Then go for the finding the value of the fixed end moment due to loading. Find out the fixed end moment due to loading. Then find out the distribution factor. After finding the distribution factor, go for the non-sway analysis, finding the value of moments at the joints at the end of the cycle. Then go for the finding the horizontal reaction at A and D as shown in this diagram. Carefully establish the direction of HA and HD so that the sway force can be computed. The sway force is P. So for finding the sway force, either you can come from the D towards A, like I have explained here. In certain parts, in the part DC, take moment about C, you will find one unknown. For equilibrium of part AB, take moment about B, you will find one more unknown. Then take from the portion AC and find the moment about C. So you will end up with some reactions, some equations 1 and 2. Solving them, you are able to find out the horizontal reaction, vertical reaction as well. Okay. Then you can assume some arbitrary value of the moment in the column initially and establish a relation between del 1, del 2 and del for the sway analysis. Go for the, after assuming the values as per the required process, go for the sway analysis, that is the moment distribution for sway force, and at the end you will find with the, you will end up with the final moments at the joints in the last row. Go for the computation of the reaction again as you have done in case of the non-sway analysis. Again the part DC, part AB, part AC to be considered differently, framing the two equations in which the two unknowns VA and HA may be there. Solving further, you are able to find out the value of the sway force S. Okay, so this is the assumed sway force S, and initial sway force you have already computed in case of the non-sway analysis. Ratio of the two gives you the value of sway correction factor, which is to be used for correction of the moments. So in the observation table, first row is for the value of non-sway moments in the members at the joints. Next row is the value of sway moments in the members at the joints. Multiplying the multiplying the sway moments with the sway correction factor, we can have the final value, and then adding the result to the initial value of the non-sway moments. At the last row, you will find the final value of the moment in the members at the joints. Using these results, we can go for the computation of the reactions, and finally the moment distribution will end up with the preparation of a bending moment diagram as shown here.